Hi guys, so brand new stuff, brand new section, still should be pretty straightforward. I hope volume was pretty easy, or volume of prisms and cylinders, because today we're talking about volumes of pyramids and cones. It comes from section 12.5, and it's kind of like the same thing as last time. It's really just a couple formulas that you got to know. Very similar to prism for volume of a pyramid. The only big difference is that you're just multiplying it by a third. So the volume of any pyramid with any shaped base is 1/3 times the area of the base times the height. All right. So this is just showing the same kind of thing that's been true every single time, where the height has to be perpendicular to the base. If you're not given the height, you might need to do some other things involving like the slant height, maybe some right triangles, maybe some special rights, Pythagorean theorem, apothem, all that fun stuff. So let's see. All right, square pyramid's pretty easy. The volume of any pyramid is 1/3 times the area of the base times the height. So since it's a square, the area of the base is just going to be 3 times 3. So 1/3 times 9 times your perpendicular height, which is 7. Pretty easy. 1/3 of 9 is 3 times 7 is 21. So the volume is 21 inches cubed. Don't forget about your units. Okay? All right, this is kind of what I was talking about when I was saying like weird stuff, some extra work. Find the volume of the regular hexagonal pyramid with height equal to the apothem of the base. Oh boy, okay. So, taking us right back to everybody's favorite, you would, like 12 is the base of your triangle that you're creating within the hexagonal base. The height of that triangle is your apothem. It splits the base in half, so we've got 6 and 6. The angle up here is a central angle, so it's 360 divided by however many sides there are. So 360 divided by 6 is 60. So the angle in the right triangle that we're actually going to use is half of it, which is 30. All right. So this is going to be a 30, 60, 90 triangle, just this part, where 6 is your short leg. Your long leg is your apothem, and it's your short leg times √3. So the apothem, because I'm running out of space, is 6√3. Okay? And then since it's a regular hexagon, the perimeter is just going to be 12 times 6, which is 72. So the volume is 1/3 times the area of the base times the height. So this is 1/3. Whoops. And the area formula for the base is half of the apothem times the perimeter. So this is 1/2 times 6√3 times, 72. That's the area of the base. But what's the height? Well, it said in the problem that the height is equal to the apothem of the base. So since we got the apothem is 6√3, the height of the whole thing is also going to be 6√3. All right? So we'll leave the √3s in there for now. Because there's 2 of them, it looks like they're going to end up canceling out at the very end. But half of 6 is 3. You know, actually, let me just plug all this in my calculator instead of me rambling. 0.5 times 6 times 72 is 216. So the area of the base is 216√3 times 6√3. So divided by 3. 1/3 of that is 72. Now, √3 times √3 is √3 squared, which the root and the squared cancel out, so you could actually just multiply by 3. So what we're doing then is 72 times 6, which is 432, times 3, which, as you can see, is 1,296 feet cubed. That's the volume for our final answer. Okay. Ooh, this is a huge picture. Something slightly simpler. Just a different formula for the area of the base this time. It's the same exact volume formula. And because it's a right triangle, we can use the 8 and the 14 as our base and height. It doesn't matter that, like, 8 and 15, 17, you guys might remember, is a Pythagorean triple. So the fact that this is 8 and 14 really doesn't change anything. Because the 17 is the height of the pyramid itself. It has nothing to do with the base of the triangle. Because we're talking about the area of the base instead of the perimeter, you don't even need to worry about the hypotenuse of the base. So we're pretty good. 1/3 times 1/2 times 8 times 14 times 17. So if we do all this in the calculator, 56 is the area of the base. Divided by 3 times 17. Okay, so it's going to get us a fraction. So let's actually do this, leave the exact answer instead of rounding off this decimal. So 56 over 3 times 17. 56 times 17. The exact answer would be 952 over 3 units cubed, because we don't have units here. That's the exact answer. Rounded off would be what we got up here, about 317.3 units cubed. That's for that problem. Okay. And then a cone obviously is really, really similar. It's just the fact that, it's just the fact that the base is always going to be a circle. So it is still technically the same 1/3 area of the base times the height, but the area of the base is always going to be pi r squared. So that's why a lot of people typically use 1/3 pi r squared h for cones. And then same thing, height's just got to be perpendicular, even if it's an oblique cone. So, super basic. The volume is 1/3 times pi r squared times the height. I don't know why I put parentheses around that. I think I was getting a little bit ahead of myself. 1/3 pi times 5 squared times 12. And we'll do both exact and rounded since it says to the nearest tenth. So the exact answer would be 100 pi inches cubed. And then multiply that by pi is approximately 314.2 rounded up inches cubed. That a little higher. And this is what I was talking about before with the perpendicular business. Even though this height doesn't pass through the center, you still have that it's perpendicular to the base. So that 25 feet is the actual height that we're going to use. And again, it's pretty straightforward in terms of doing the problem. And the 9.1 is pointing to the entire radius. So that's easy. So let's see. Okay, so something like this, because the decimal is so weird, I probably wouldn't ask you to leave it in terms of pi, especially with the 9.1 originally. So we can just multiply this by pi and call it a day. This is approximately 722.7 feet cubed. I don't know why I write my cubes so big. They should be kind of like an exponent, you know? All right, really quick. There isn't that much else to say. Like, this book doesn't really go into composite figures in depth, but kind of like with surface area, the volume of a composite figure, like, you can just break it down into separate pieces. Like, in this case, it would be 2 cones and a cylinder, and then add them up. And the nice thing about volume is because it's space, you don't have to worry about taking anything out. Like for surface area, what happened a lot with, especially the last question on the surface area check with the prism and then the pyramid on top of it, is that a lot of people forgot to take out the portions of the bases that weren't part of the exposed surface. Like that prism, one of the bases was not part of the exposed surface. For the pyramid on top, the one base was not part of the exposed surface. So if you did the entire surface area, you would have to go back in and take out those two areas before you added the prism and the pyramid up. With volume, you don't have to worry about that because it's just taking up space, you know? So we could just do volume of this cone plus volume of this cylinder plus volume of this cone. And then we're good. So I'm actually going to go from the bottom up just because this 40 is blocked off right here. And we're going to get into this cone in a little bit. So 40 is the height of this cone on the bottom. Height of 40, radius of 21. So 1/3 pi r squared h, 1/3 pi times 21 squared times 40. And I'm going to leave everything in terms of pi until the very end when we add it all up, because it should all work out nicely. All right, so the volume of that first cone is 5,880 pi centimeters squared. So we have this 35 blocked off for the height of the cylinder, which is good, and the radius is still 21. So the volume of a cylinder, in case you forgot, is just regular pi r squared times the height. So then we're going to plug all that in. Radius is still 21 times 35. So the volume of the cylinder is 15,435 pi. This should be cubed. This is going to be a ridiculously big number by the end of it, but it's fine. So in terms of the top cone, I hope you guys kind of see where this is going. The 70 right here is blocking off from the tip of the cone to the bottom of the cylinder. But since we had the height of the cylinder is 35, the height of the cone is just going to be the difference between that entire 70 and this 35, which is 35. So it's the same dimensions as the cylinder, just so happens, but because it's a cone, we're not going to get the exact same number because the formula is going to be different. So it's 1/3 pi r squared h. 21 times 35. So we could honestly just take the exact same 15,435 that we got earlier and just divide it by 3. And that, in terms of pi, is going to be the volume of our second cone, 5,145 pi. So when you add, let me do centimeters cubed. So when you add them all up, 5,145 plus 15,435 plus 5,880 gets you an exact answer of 26,460 pi centimeters cubed. But the directions did say round to the nearest tenth, so we are going to multiply this by pi and get a ridiculously large number of 83,126.5 centimeters cubed. We can handle big numbers. It's fine. And the only other thing here, I believe, is just a quick refresher. Yep, this is the only other thing here. That didn't do anything. A quick refresher of everything we've talked about in terms of volume. Prisms, cylinders, pyramids, and cones. The very last thing that we're going to do in terms of volume is finishing up section 12.6 and talking about volume of spheres. So we are almost there, you guys. Almost there with the end of the school year. We are not there yet. Somebody asked in the geometry hangout group chat if there is going to be one last check. There is going to be one last check on volume. There might be some surface area stuff thrown in there as well. I haven't 100% decided. I am going to post something about it on Google Classroom very, very soon if I haven't already done so by the time you click on this video. If you are not a part of the Geometry Hangout, Google Hangout chat, I don't know why. I know a couple of people have messaged me about the Hangout chat. I ended up kicking out a couple of people who were in the Google Hangout chat multiple times. If that is you, you should know who you are because I did email you before I kicked your second account out. And if you are trying to get back in and you're having trouble, you should also know who you are. I am still working on that. I didn't think there was a limit for Hangout chats, but I guess there is. And honestly, by this point in the school year, there's like a week left. I'm going to try my best, but if there's nothing I can do about getting you into the Hangout chat or getting you back into the Google Hangout chat, I'm really sorry. But I know I told this to somebody who had messaged me about not being able to get back in after being kicked out. If you have been kicked out of the Google Hangout chat and can't get back in, or you haven't been able to get into the Google Hangout chat and want to know what's going on, because like there's a lot of important information that people, or a lot of really good questions that people ask in that Google Hangout chat. So if you're not in it, I would highly recommend finding a friend who is in the Google Hangout chat and, just asking like, hey, can you send me screenshots if there's anything important that I miss? I think that would help a lot of people, especially so I don't have to repeat myself 100,000 times. I was going to say something else and now I can't remember. It's just good to like help other people out and stuff. And it really doesn't take that long to hit a couple of buttons on the side of your phone and then send it off to a friend on, I don't know, what do you guys use? WhatsApp? I don't know what you use to text. iMessage. It would just help a lot of people out. I know that you guys are friends, or a lot of you guys are friends, especially in between classes or between classes. I don't know. I feel like I'm rambling too much. We're almost done with volume. We're almost done with the school year. We're not there yet. If you're running into some problems with Hangouts, reach out to a friend because I don't know if there's anything I could do by this point, unfortunately. And yeah, if you have any questions, you guys know where to find me. And keep up the great work. We are almost there. We are so close. You guys are doing such a fantastic job. I'm probably going to say a whole bunch of stuff in my last video ever about how awesome you guys have been online. And I'm already rambling about it. So I'm going to stop. Let me know if you have any questions. And I will talk to you guys really soon.